Good afternoon and good morning again. I hope that your that the coffee has the coffee first was okay, and second that you had a lot of things to discuss about the first presentations. I would like to continue with the third presenter, which is Professor Ike Guo, from the professor at Imperial College in London. And we got in touch with each other because there's a huge multidisciplinary project in London going on, which is called the Digital City Exchange, and that is all where it's all about. It's not just either IT or design or data scientists or business people or salespeople. It's multidisciplinary, and I think that is one of the essential issues of this whole big data thing. So I would like to give you the word, please.
Honored to be here to present some of our work in Imperial on the digital city. So we already heard in the first session the health and about the digital life and human. And in fact, the city was no different from human. And now, because of the sensor technology, and we are now not just can understand human well, our behavior, but also can measure city in the real time to understand a lot of the dynamism of the place we are living. Of course, here's many sensors here, I'm sure. Large proportion of them come from Philip. And of course, the sensor is great, and the sensors that needed technology, but to understand the digital city, to actually make a real digital city is not just technology. The most important thing we already heard now today is the real essence of the big data is data become a new natural resource for human being. Because of this resource, we are starting to making products out of this resource. And we already heard this quantified yourself is trying to making some digital products. But then there's a very important issue here now. Suppose we already have this kind of digital products ready, and for our life living in the city, and how can we actually use these digital products? How can we make this digital product have infrastructure to actually make it and trade it and make it into economy? So this is actually one very important research subject of the digital city exchange. The word exchange used is really hinted. There is the economical factor of the big data. So here is the picture here now. We really think about if to make a city works, a digital city works, you need to investigate the data impact to the infrastructure, urban design, and also the policy on the economic development, and also the impact of the digital products to the social capital. So this is with the Digital City Exchange project, which is 6 million funded by the Research Council of the United Kingdom. And it's a very unique project. It's led by the Business School of Imperial College and worked with and the Faculty of Engineering. This is a quite interesting combination, and we never had a very good experience of working with economists, but this time we're not even working with them, they actually lead the project. So I'm responsible for the informatics part of this project. So today my talk will be largely on the technical side, but within the context of this big picture, where the city data, the sensor data from transportation, from energy, from water, from waste, for all the kind of aspects of city life should be integrated together, right? To do the analysis, to make different kind of digital products. That's number one. Number two is we have to think about not only making digital products and thinking about how the different digital products can be combined to provide the different services to the different players in a city. So it's a 5-year project. We are now about 10 months into the project. And there's some result already come out, which I will report today. So here's the 6 work package here, right? You can see WP1, WP3 is more technical package, which I lead it. Is on the understanding data and to the data integrations, build the platforms to enable people to actually integrate analysis, but also building the digital products. And then the WP2 and the P4 is on economists, and they really try to understand the user behaviors towards data products and thinking about a new business model, think about trading model of digital products. It's like the question I'm asked to a gentleman about, for example, the ownership of your own quantified data and how you actually trade it. So the thing like that. And then now we have the simulations and also have some kind of case study build. So today's talk, really, my focus is on the technical part, because I think this is quite important. So how can we develop the platforms which allow the sensor data from all the aspects of city sites can be integrated and also can build up upon it the digital products. The core objective of the informatics in this project is have a system views of the city life. Now here is from our experience. I've been working on healthcare for quite a long time. I'm very interesting here in the first sessions, and many things we're talking about is body sensor, right? So in the body sensor, the most important thing here now we want to achieve is a systematic view about of the dynamics of our life daily, right? And then so that you can actually reflect on the service side right over there, like a healthcare service, like emergency services, and like well-beings, and like insurance. That's on the service side. That is from health point of view. City have no difference, right? But city is just to measure different things. And when you measure here now is the energy consumed, pollution, traffic. This is we call phenotypes of a city. But this information will be measured and is also will be stored. We heard about a lot of the cloud, of course. This is for the information sharing. So you will share this information all together. But the most important thing in this analysis, in the past, all this analysis of big data is always a single trade, right? If I analyze energy data, I only analyze energy. If I traffic, only traffic. But really try to understand the city life, you have to put all this information together. So this is one example of the urban energy systems where I try to, for example, this is energy data, is the profile of all the devices, and then also the price of the electricity. And then the thing is, for example, in this way, and if you can have the three information measurements, profiling, and also the price together, and you can actually create interesting digital products, provide the aggregated way to use scheduling your energy consumption within probably, for example, a district or one building. But this is more than just money. You can actually associate, for example, on the electricity energy generation on the supply side, you can actually put for example, carbon constraints into it, and then now you can provide some kind of a way to actually optimize the production side for the green factor. And the same thing here to do is also on the pollution, right? In the city, most of pollution is caused by the traffic. So, but also the pollution model cannot be generated easily. If you just measure the pollution, you may have a quite nice profiling system, but you cannot really have a very good use, because although you don't know how the pollution generated, you don't know how the health affected to the humans, and how you don't know how to control it properly. So in this way, for example, here, if we combine with the climate data, combine with traffic data, we probably can create a real-time 3D pollution maps of the city, which will be very useful. And you can think about it, you can actually potentially pricing each buildings, right, in the city based on this pollution index. That'll be quite interesting too. I mean, transportation, Sean already mentioned this morning already, so I'm not going to say it again. This morning's application is a typical application to put the human stress measurement with the traffic scheduling, and you can provide actually a personal scheduling system to your satisfactory. So this is pretty much the same thing here. So the challenge of here now is really come to how to integrate all this information, right? One thing you may think about is, use a small data concept, right? You build a big data warehouse, you put all this measurement together, and then now you do data mining. But it certainly doesn't work in this case, because one thing is the dynamic of the data, another is the huge amount, right? So you merge this data together, I don't know how much big database you will create, and no database will be created in this way anyway. The second thing is really that each individual measurements and will create, and they have their own, the model created from the analysis of this data. The really economical way clever way is try to integrate the models and to build the models over this multiple modality. And then you create a structure which allows you to combine different models together to actually doing this comprehensive analysis of the city. So I will quickly overview about the sensor informatics, how we deal with sensor information. The traditional way, the small data way, is really you think about just thinking about all the sensors coming in, just put it in the database. And then you can run the analysis package. If you want more data, just ask the sensor network to get more. So that's probably the standard way we are actually quite familiar with. The other model is so-called model-driven. In this case, is actually much more interesting here now is the data was not really the sensor and the model built from sensor forms a central part of the management. The model is driven when you sense, where to sense, right? One of the very important thing here now is like our human, right? If you don't really measure temperature every minute. You only measure temperature when you find out you feel not very well. So not very well feel is a model. And in this case, you will use a model to actually control the data acquisition. In this way, you build a model-driven sense approach. It's more like a Bayesian, right? And you actually have a prime model here, and then now you check with the sensing facts, and you find out the data maybe not very fit with the model, and then in this case, you acquire more data and update the model. So this is more like a model-driven approach. The third thing is you have to put the model together and put the information together. This is a semantic approach. You need to specify, right, the thing you sensed, its background, and you have to specify your sense itself, right, the resolution and the quality of the sensor. And also you have other information related to the whole model integrations, the relationship between the different modality. So all these things have been structured, specified ontology. So interesting in the DC infrastructure, we need all of them to there because we need, of course, we need a query layer, we need the basic information because you have to drill down to the basic level. You need a semantic representations of all the different aspects which you sensed. And then you need a city ontology describe the entire structure and the entire background you're actually working on. And then the last thing, you have to control the sensor, which I talk about model-centric. And it's, of course, is run on the cloud. So this is give you the basic concept here. So the system we built, I will probably have a quick overview later, is enable you, our engineer in the college, to actually all the different people working on the city can use this infrastructure to actually use the model to actually drive the sensing and put sensing information to improve the model study, combine the model together to actually build things. One example I'm putting here is the pollution traffic example, right? So this example is a very typical example where you can see sensor from the computing department and then the modeling from our civil engineering department work together to actually build a pollution structure modeling system around this Imperial College. Around the Imperial College. So you can see here now, with city ontology, describe the city, and this description will generate a geometric mesh, right? And then we use the numerical model to actually set up the initial models of the whole area. And then we use the combined different models. This is combined with the models from the climate, the humidity, wind, and also the temperature actually impacted to the flows of the airflow. And this is the emission model of a vehicle, each individual vehicle, where they drive along the streets and the emission of the different pollutants. And then within this model here, and we build up also mobile sensor on the car to actually do the measurements, right? And the whole thing is doing here now is the measurements we're doing here now is to compare with the simulated results from this numerical model here and check their consistency. And for the non-consistent bits, and we use technology called composite sensing to actually find out which area you should put the sensor, so therefore you can update the model so that the model and the final word will be fit. And then afterwards, this model will be used as the abstractions of the whole, this area on the pollution and the traffic relationship. So you can see in this world, it's not just simple data mining anymore. It's much more sophisticated to combine with the mathematical modeling with observation. So as you can see here, the red bits is the area which the numerical simulation, our mathematical model doesn't fit very well with the observation. Here, we did a change, okay? So that is the system. So therefore, the software we build is to enable this sort of analysis. So the system we built here now is called WikiSensing. It's a 5-year project. We're only 8 months, so it's still quite a lot of things to do, but the methodology is here clear. So this WikiSensing, why we use Wiki here is because, again, we address the issue of the big data. Big data doesn't analyze by a small group of people. It's the open analysis by many people. It's like a Wikipedia. So this structure is actually built upon the Wikipedia infrastructure. So we put data here in the big data structure using MongoDB and all the other Hadoop stuff. And this is underlined, put all the stream data into it. And then we allow scientists to actually do collaborative research over this data. And there are some kind of infrastructure building on, for example, the ontology-based sensor information management. You need to submit your ontology, you submit the sensor as a one sensor descriptor, and also the area you have to featureize it with the ontology here, and when you put into it, it will create a data space for you for this particular sensor. And we have a stream data management here, and also have a virtual sensor concept to actually create the sensors or discrete measurements on the discrete area. So in order to create a continuous space, you create every geology points, you will get sensor value. You have to do the interpolating. So this is the using technology here. Quickly go is this one allow you to have the different sensor data types. So you can link a different sensor into it, right? And then you can measure it in a uniform way in a data cloud. And from that, you can visualize it on the map. So hopefully in the future, we'll go to 3D map. At the moment, it's only 2D. And this is a bit like when you have one particular sensor, you know what types, you log into it, you specify the sensor type, use ontology, it will create you immediately a data space for you. So this is pretty much the one particular sensor registration here, and give you all the types and also give you a simple visualization on the map. And then here now is after this one, this all data storage. The second one we want to do is we allow the model builder to actually use the data sets to do the analysis. Remember, this is the WikiSensing. It allows the collaborative way to build a model. So this is the way here is you put, you browse data, find data you're interested in here, and then you build a model on it. And then the most interesting thing here now, and you can even link the model, use this kind of visual composition to build a model in the interesting way, combine different models. Here is you can check, this is like an app store, right? In the kind of like a Google App Engine. So you can check how many models there, and all the models have a web service linked to it. And you can actually, in the future, probably you can sell it, but that's why you have the purchase pattern button here, but that's only for the illustration, but it's not really here. And then this one is give you how many models there, who did it, why did it, and when did it. And then this gives you the provenance. And then you can actually build a new application by combining these models or use the raw data to build your own models. So I think I can have a very quick way to actually show you, I don't want too much time, to actually show you how the system actually for the model development point of view, how it works, right? So this is working on the area. Just be quick going, right? So this is browsing the data you want to interested in. And here is the model. This is traffic, the pollution one, okay? So this one, for example, here, you have the land usage data, right? And you have, for example, the area characters, population characters, transportation profiling, and you link, this is the model name here. Come out is actually the traffic network, and the network combining with the model I showed you before is give you the emission model. The emission model come out with actually the pollution, right? Each time pollution profile. And pollution come out is with the climate data together, and it will come out the air quality of the area. So this model, you just join them together. And then we'll show you in the area here, hopefully, give you the pollution scope. Right? So this is this environment to see how this model can be wrapped into a standard API. So therefore, in the REST forms, so you can combine different model together. You know, contribute model as a service. Right? You can publish your model. Right? And after publish it, it's become digital products, and then you can join together. Okay? So I'm not going to. All right, so this is, if you go detail, this is the API looks like. Okay, so. And also underneath, the ontology here is pretty much specified. This is onto the sense ontology, and have a city ontology. And then you have the data conversion model built on it. Some sense are very expensive, some sense are very cheap. How can you normalize it? So this one is all built in as a part of the knowledge management practice. And the application already done. So very interesting thing is we build these products and use this model, and now our economists were working there to have a crazy idea to build all different kind of the digital products. One of the products they built, we are doing now, is a future advertisement of selling house, the virtual estate. So what you're doing here now is when you sell a house, as I said here, you're not just price the house based on the area, but actually give you the noise index, pollution index, right? Actually, the risk factor for certain disease all there to build it. So it's kind of a weird thing, but you know, this is what the digital products can give you. So actually, this is the 3D maps, right? So of the city. So this is one of the products. There are many other products we are building, right? So based on the model engineering department generated. So I think by this I summarize my talk. So digital city exchange is not just engineering projects. It's really combined economics with engineering to create understanding of city life and to examine the benefits of the digital product and the service and to the human life. Right? And then we really have to think about how to create this kind of products. So new infrastructure is needed for integrate, for analysis, for model, how to make these digital products, right? How to trade these products. So my part on the informatics structure is based on the big data architecture to create an environment to facilitate our research, to build the prototype of the innovation, and then understand the business model, to actually, and as well as the consumer behavior, so therefore we can have a real place, can play on this digital economy. So this is the goal of this project, and I hope it's useful. Okay, thank you.
Thank you very much. Are there any questions? Of course, I have one question.
Yeah.
So this model has been developed, or is being developed currently. Now it's being used, let's say, partly in London, but it can be theoretically be used in any city or any location. Is that correct?
Yes, I think it's the model. It's a 5 years project. Only started last October, so last December actually. So we are about 9 months into project. Some of them are built. The platform is built. Some part of the like a pollution traffic this kind of model is already used and be prototyped and to prove the concept.
Yeah.
But in the next 4 years, right, and we will have intensive development. But one of them we are really working very closely is with healthcare. So for example, we will use the pollution model to understand risk factor to certain chronic disease, particularly respiratory disease like asthma. Mm-hmm. So, and then we will research on this and also research, for example, temperature and weather to the older people. So this kind of thing will be based on distributed. And then you think about how to create a service model. So this is involved healthcare and economists and us to actually create this kind of virtual experimental space factory to do this kind of little product, but without involved the real.
So the Eindhoven city, for instance, could take your model, could put their parameters in of the specific city, and they could use it for, let's say, all sort of healthcare business.
Yes, digital city is not digital London. Yeah, definitely.
No, it's not just London.
Not London, not London. We're beautiful, the world. Yeah.
Okay, thank you. Are there any other questions? Okay, thank you very much.
Thank you.
Now we move to something completely different. From ontology and cities, we move to visualization. And we invited the company Catalog Tree with 2 speakers, Daniel Gross and Joris Malta. And they started their company 11 years ago. And I think the floor is yours. Where are you? 1 or 2, yes. So it should, yeah. Microfoon ligt.
Can we share the microphone? I can use this. Okay.
And I have the microphone. Oh, it's okay.
No, it's okay. I could use this. It's fine. I myself had a very exciting morning getting here by public transportation. I just arrived just a minute ago, so I'm. Phew. That was interesting. Yeah. So we are a graphic design studio, a very small graphic design studio of only 3 people. And we have a wide variety of activities. We create printed matter of all kinds, books, posters, things like that. We've been trained as book typographers. We also build websites and design exhibitions, etc. We have specialized over the course of the years in visualizing data. And we do this mainly for newspapers and magazines, and that mainly in the United States. One theme that is important to us that underlies all of these activities that we do is that we're very interested in self-organization of content. So we don't really tell every word or data point what to look like exactly, or where to be on the page, or things like that. Instead, we try to assign behavior to these numbers or words, and by this we let the information evolve into its own design. This is one important theme to us. And another thing is that we really like to create our own tools for doing this. So we write our own software, sometimes in collaboration with others. And sometimes we create hardware, but we're not going to talk about that today. So talking about self-organization, we have a picture that might clarify a bit what we mean by that.
It's an aerial view of Church of Our Lady in Dresden, in Germany. And it's on the day of its reopening in 2005. Of all these people are queuing up to get in, actually, the church. And they're standing there in the queue for quite a lot of hours. I think it took 2 hours to get inside the church. And as we've recognized, or we discovered that photo, we were struck by this beautiful shape of the queue, because there's no single reason at first sight that these people are not queuing up in a straight line, but they are queuing up in this beautiful arc somewhere. It's kind of spiral. And we thought, well, maybe it would be, the only reason could be that people who are standing in the end of the line want to catch a glimpse when they are able to enter the church, actually. So everybody is doing like this. So, and by this, this shape is automatically generated with no designer, no graphic designer, no product designer involved. It just generates it automatically itself.
So the project that we want to show you is something that we finished in late 2010, early 2011. And it's an interactive documentary on financial trading in the world, which is a world that is changing rapidly. We created this documentary together with Marije Meerman from VPRO's Tegenlicht, Backlight, which is a current affairs program on Dutch national television. And she had made documentaries about the financial world before, you know, she teamed up with us to create a new project from scratch. When we started out, we wanted to explain in this project how trading functions today. And when we started out, at least Daniel and me were so naive to think that this is Wall Street, that this is what trading looks like. You know, the guys with their books and shouting their orders and everyone is panicking and everything. But in fact, as we learned quickly, Wall Street is a museum. It's not, you know, the majority of trade doesn't look like that anymore. It looks much more like this. It's a network of computers that trade amongst themselves using algorithms that are programmed by mathematicians. And these mathematicians, they use huge amounts of trade data to analyze and to create a model of the world with which they predict what will happen next, and they make a lot of money with this. And this has very serious consequences to the financial world, but ultimately also to us. One thing is that, of course, these are not cheap computers. You know, they're very, very expensive machines, right? An average trader or someone who's trading at home, of course, cannot get into reach of these machines. So there's very little parties, very, very large investment banks and institutional financiers that can actually afford these type of machines. And they hold the majority of the stock market. This is one thing that changes. Another thing that changes is that the algorithms that are trading are themselves, this might be a benefit of it, are not corrupted and do not know fear and things like this. So you might say that they take a little bit of the emotion out of trading that people might have. This might be a benefit. Another thing that is happening is that it's tremendously quick. So they process about 3,000 transactions a second now, which is about 1,000 times faster than you can blink your eye. And of course, this is also very beneficial to the people who are trading that way because they're making money really fast. But if anything goes wrong, it goes wrong with that speed. And while we're doing our research on this project, on May 6th, in 2010, there was a flash crash on the New York Stock Exchange. It was the fastest and deepest crash of that stock exchange in its history. And I think in about 7 minutes, $800 billion were lost and then magically reappeared after a short period of time. We thought that it would be very interesting to make this the focal point of our project. So Marije went out to do interviews with traders and analysts, mathematicians who know about these things, to recreate or find out what actually happened on that day. And Daniel and me, being specialized in data visualization, we got the actual trade data, the historical trade data of that day to visualize. So we now want to show you a small clip of what the documentary feels like, and then we tell you a bit more about the app that we created for it.
Where are you on May 6, 2010?
Here working. May 6, 2010. Yes, I was here.
One eye on the market, one eye on my own profits and losses, and then my ears and mouth doing whatever else they have to do.
It was the first
really down day that we had in a while.
And the market basically looks like it's going to go to hell that day.
It wasn't just minutes later, it was Armageddon. Oh my God.
Here you go, I'm told it's 835. The Dow ticker, wow.
I feel like when the Dow hit nearly down 1,000 points, you're like, really?
87 even start trading, 86 even start trading, 85 even start trading here, my guys, all the
I saw
way
that
down.
panic, you know, and then I started watching CNN or one of those channels.
What we're seeing right now, I mean, I believe maybe unprecedented. You're not talk about capitulation. Let's take a look at P&G.
They're gonna probably halt trading. We can't stop the selling.
So you've got the general picture, the big picture, although it's still over a very short time scale, and then you've got the detailed picture of the individual trades. See, there's a little bump there. That's almost the more natural scale, whereas even here at this level, it's something that seems to be quite big. So there are some trades that are kind of normal, and then there's yes, funny, these big, you're right, these are really big, aren't they? This one it starts off at 42 and it goes all the way down to 1 cent. Lord above, it's amazing. Oh my gosh, I turned away when that happened. So who is it selling Accenture at 5 cents?
It has to be a machine, right?
Yeah.
Essentially, they're just rocketing back and forth between.
Yeah.
Only a machine can do those, right?
Any thoughts of what's going on here?
Steve Jobs didn't die. There's no reason for Apple to be falling to zero.
Right.
And so they start trading, and then, I mean, the back up in, 7.5 minutes or something, it was incredible. And that couldn't have been people not reacting that quickly and not in that kind of volume.
Well, one key thing is how automated is all of this, all of these trades?
And that's when the delay started, a few hundred milliseconds, and then a few seconds, and then 5 seconds, and then 10 seconds. And then some of them went all the way to 36 seconds.
So the delay in the data was 36 seconds.
Right, but the way that the timestamps occur is it hid the delay. So you couldn't see it. The Dow Jones, should have been here. The real price was here. The delay in the system caused it to appear like it was over here. So when people were seeing the Dow dropping, this was actually really where the market was at that moment in time.
We operate on this time scale where, where 5 minutes is pretty fast. You could go out for a cup of coffee and come back and find that you'd lost $1 billion. That would ruin your day. And yet, for these computers operating in microseconds, it makes no difference. So I think it's the circuit breakers is a case of sort of imposing our time scale on the computing time scale.
Could it happen again?
The same mechanism that caused it on May 6th is still there.
So this documentary was produced as an app for Apple iPad, and you can. In the Dutch App Store, you can download it for free. In the international App Store, it costs you $1, I think. And it's a full-length documentary of an hour that examines this event. And this is part of the interface that you're seeing here. What basically happens is that the documentary itself can be seen as just one direct line of just one narrative. And then whenever it's appropriate, extra information is offered to the user of that app. What you're seeing here, it's always a bit awkward to show this on a screen because you cannot slide it, but there's the main or the key scenes in the movie are there. You can slide through it, and you can step into the movie at any time or just play it from the beginning to the end. And what was interesting to us was that we were able to create some of the visualizations before the documentary was finished. So the people who are interviewed are seeing the visualizations that you can later view yourself in the app. So you have their comments on what is going on, and you have the actual visualization there as well. So they're using the app in the app, as it were. This is one of those visualizations here. So this is the trades of Procter & Gamble. Every dot that you see is a transaction, and the height is the value of that of the share, and the speed by which this goes by is the actual speed of the trading that went on in this place. Technically, this was interesting because we were able to. This runs for about an hour, but it's not an hour of video because then the file would be really, really heavy. You know, it's already over 400 MBs. This is actually running from a data set that is embedded in the app, and so we have many more animations like that are actually using or generated on the spot using the data. So here's an image of Apple.
Oh, sorry. Yeah. This is, again, an aerial view of New York Stock Exchange, because right now they are building these kind of data centers which are providing a real-time backup. And these data centers are, of course, not built somewhere near of Manhattan. They are built somewhere around. And actually, trading takes place at these data centers. And they call this the data donut, because all these data centers are built in a donut shape around Wall Street. Its outer circle is about 70 kilometers wide, because if some data center is situated more at a farther distance than 70 kilometers, the glass fiber network is too slow. So they have this diameter. And of course, because it's a donut, it has a hole in the middle. And this is why, this is because they have to take into account that maybe it could be a nuclear attack on Wall Street and Manhattan. So no single data center is built in a 30-kilometer blast radius. So the rest is in this black area. And there are kind of real estate brokers right now who are selling this land and selling these grounds. And because there are some woods in, and there are some swamps where you're not able to build these kind of data centers. You do not want to build them next to streets where hazardous goods are trafficked. And you do not want to build it next to a railway line, for example. You do not want to build it in an area with high crime rate. You do not want to build it underneath a flight route. And of course, New York has 3 of these bigger airports. And you do not want to build it next to a nuclear power plant. And there's one big one in the north and another big one in the south. And they also got this blast radius around it. So the area which is black still is kind of virtual Dubai. And the real estate prices are rising there rapidly, because everybody wants to build his own data center there. And if the company has a lot of money, they build an exact copy right next to it as a kind of failure. So if one data center fails, the other one pops in and then just continues, or even quadruple. So they build 4 identical data centers next to each other, where 3 of them are switched out at that moment. So this was also kind of animation we did for this application.
Yeah, so because the iPad has an internet connection, we also wanted to show some live data. We learned that this type of data, if you really want it to be live, so to, you know, really when you want the data when it's being produced, it's very expensive. You cannot really do that. So the longer your delay, the cheaper it gets. So this map here shows the major indexes in the world and their current state, the height of the index, and you can see if they're open or not. And this is a regular day. So green indexes are in the plus, reds are in the minus, on March 11 in 2011, there was this major earthquake in Japan and the tsunami that followed it. And on that day, the map looked like this. And this kind of shows that negative effects like that ripple throughout the world. It just went with daytime throughout the world. This visualization didn't make it into the app. We were looking at, we heard that this crash originated from a trade in Chicago. And these are all the trade platforms in America. So there's Chicago is down there, Cincinnati, Boston, NASDAQ on the top, and we wanted to see if we could find this in the data. This was a sketch to test this. So these are trades of Apple, and every circle that you see is one transaction. But it's really not very informational. It's just really, a pretty picture. We've been looking at it mesmerized for hours, and then decided, nah, you can't really tell anything from this. So we're probably going to turn this into a screensaver or something. It's probably best, to do this. So to conclude our talk, right?
Yeah, maybe it's the last aerial view and the last picture we want to show. It's an aerial view of a cornfield in somewhere in Netherlands, I think in the south. And the story goes that a young kid took a lot of drugs, mainly cocaine, and then just hitchhiked his SUV of his dad. And then went on fun riding. And soon he was followed by police cars. And then he had this bright idea to enter a cornfield because corns are quite high, and he thought he would be invisible there, and drove there panicking in this cornfield about half an hour. And what he didn't know was that the police agents just were waiting half an hour on that street, and finally he was able to find the exit. And then just crashed his dad's car into a tree, and then he got arrested. But what stays is a beautiful infographic, and again, it's not designed. Of course, it's designed, but I think the boy has a lot of different problems at that moment and designing. So, but it looks beautiful, and it's a kind of infographic of pure paranoia. So it's and it would be quite difficult to make a design of pure paranoia if you want to. So yeah, it's the last slide.
Thanks a lot.
Thanks a lot.
Thank you very much. Are there any questions? No, I never ask this again because nobody has the first question. I do have a question. Is there any drugs related in general with all your pictures or not?
Which else was drugs?
Yeah. So if you talk about, let's say, healthcare related things and health and well-being, you showed your money and transfers, those sort of things presented. What is your vision about? Are you working in that field as well? Are there things to be visualized?
Not yet. No, we haven't been able to work with health-related issues. But of course, it's very interesting because it's talking about financial transactions and everything. It's completely abstract, and it's really difficult to imagine that this has an effect on you as a person. Where with health-related issues, of course, is this very personal data. This maybe this requires much more tact or something. Or when working with this financial data, we really had to look for the drama in order to make it work in a documentary like this. It has to support a certain narrative. Of course, you cannot do this with looking for drama to thrill with health-related data, I guess. Yeah.
What do you see the market for? I mean, the market visualization is getting more and more. And you haven't been the whole morning, but all the data with all the big data coming up. How important is visualization? I mean, the introduction by Sean Connery was about the fact that when you talk about big data and connected devices, you have different business angles. And visualization is one of them, but how important do you think that is in relate to all the others?
I think it's important to actually tell a story which is interesting. And of course, right now it's quite easy to get your hands on big data and to acquire huge masses of data. But if you want to tell somebody else, your story has to be interesting in some way.
Yeah.
So it's not about just presenting the data as is, as raw data, because then it's like looking at a TV screen in the middle of the night. So it's black and white dots, but they are telling nothing actually. So it's for us as graphic designers is to explain it to people who are absolute laymen or laywomen, and to tell an interesting story, to make it look interesting, and that somebody wants to dive deeper into the data.
Okay. Any questions? Okay, thank you very much. Thank you. The next speaker just arrived from Beijing, and not just the airport Eindhoven, but by train, I suppose, or by car in Eindhoven. So it's Jeroen Tas. He's the CIO of Philips Corporation, and he started after his study at Philips, but then he left, and then he went to other companies, and he started an own company, and sold that, and then returned to Philips to help change the IT and the CIO, all things related to that for Philips. So I would like to give the word to Jeroen Tas, but he has to connect his laptop. Yeah. Oops. What should I do with this? See. Okay, Jeroen Tas.
Well, good morning. I just flew in from China. Big country, a lot of big data, and a lot of big opportunity. By the way, who read The Third Wave by Alvin Toffler? Like 4 or 5 people. It was written in 1970, and it actually predicted what is happening now. And the big theme of the book was the third wave after the agricultural, industrial, the information age. And the big theme was actionable knowledge. But it took 32 years to actually get there. So the book was written in 1970. And why? Because the technology was not ready. The technology was not ready to give us very cheap sensors, make sensors ubiquitous. The technology was not ready to handle petabytes of data and do that and have elastic processing that allow us to analyze data over thousands and thousands of computers at the same time. So while the ideas were there, it's only now that things are happening. And that's what I want to talk about. I want to talk about what does it mean for a company like Philips. And what you'll see is it's actually nothing short of a revolution for Philips as well. And it is a revolution for many of the companies that see the opportunity, not just of big data, but a convergence of a lot of technologies that will enable completely new ways to deliver products, services, and to actually build winning value chains. So for those of you, I think there are many people from Philips here, but for those of you who don't know Philips, and probably that's very few people, but let me tell you where we are as a company. We're in the middle of a business transformation. I think that business transformation is on the one hand driven by necessity, a continuous need to stay at the forefront of the market and to compete with big players that increasingly come from where I just visited, rather than our traditional competitors. We're in 3 sectors. Healthcare. What's happening in healthcare? Big changes. Healthcare is going to spread its wings. Today, the US spends 18% of GDP on healthcare. That's not sustainable. Something has to change. Still, there are billions of people without access to affordable healthcare. So you can expect a big revolution there. But that revolution will be based on technology. It will be based on big data. Because ultimately, it's the big data that will help us give insights, that will give us clinical decision support, and that will help us to treat or better prevent illness for billions of people. And that's only happening now. You know, Philips as a company was very much focused on hospitals, on supporting the clinical departments of hospitals. Increasingly, Philips is focused on providing affordable healthcare for billions of consumers and patients. If you look at lighting, that industry is undergoing a big revolution. You know, 120 years we had the same technology. You know, we iterated on that technology, but only recently light has gone digital. What does it mean? Every bulb here will be directly addressable. Every bulb will contain sensors. So we will not only be able to control, but we will be able to sense complete environments, homes, streets. We will be able to drive down energy cost. And right now, energy constitutes around 20% of all energy consumption. Lighting consumes around 20%. So if we can impact that, we'll have a big impact, not just on how we consume energy, but also how we can optimize light for well-being. And if you go to our consumer lifestyle, you know, traditionally a very product-oriented business, increasingly becoming a solutions business. You know, big themes like mother and child. And Philips right now is working on new products. For instance, a blanket that contains blue LED lamps, so you can sense the skin of the baby and then adjust the light to make sure that the skin of the baby gets optimized. You can have all vital signs tracked in the blanket. So that means you wrap the baby in a blanket, you can truly monitor the health and well-being of your baby. And then all the products related to that. So we have another big area is, for instance, our aging population. You know, Japan has a huge aging population. But do you know what the next big aging population will be? China. The one-child policy can help you predict what life's gonna look like 10, 20 years from now in China. So Philips is obviously very well positioned to help seniors live, you know, healthy lives. Why? Because we can help monitor. We have a product called Lifeline that when a senior falls down, immediately you get an alarm and an ambulance will come. Now, we can basically track much more. We can know all the vital signs before the person falls down. We can help people. I think you've talked about quantified self before this. You know, you can already track a lot of vital signs in a very, very simple way. So if all that information comes together and you combine it with demographic data, with sociographic data, with psychological data, psychographic data, imagine what you can do. So we're at the forefront of a true revolution where I believe Philips can play a major role as a company to add to the health and well-being of billions. And that's the challenge we set out. But that's a long way still from where we're starting and where most companies are starting, because most companies are product-oriented. They haven't thought through full solutions. And even if they're thinking about it, how much time will it take before you actually collect the data, get the insight, and makes them truly that actionable knowledge that Alvin Toffler talked about? So that's the challenge we see ahead of us. But we believe we're well on our way, and we believe that we can make a major impact on billions of lives. So now, my role as CIO of Philips is to make sure that we enable the company to actually benefit from these big opportunities that we see ahead of us. So basically, there are two areas that are distinct. You know, the first one is how do you connect? How do you connect with consumers, with customers? How do you get a real-time sense of their well-being in their context? Oh. That's correct, that's me. So how do we help then to differentiate in the marketplace? To make sure that we develop and deliver these products and services that address real needs. That address real needs for well-being, that address these real needs for health. How can we support that integration? You know, we have connected products, we have connected consumers, we have connected supply chains, we have connected partners. So how do you bring this together and manage it? How do you make sure that you're not creating new islands of data that you then, you know, that stop you from being effective across the value chain? At the same time, how can we be agile as a business? So how can we create these winning value chains? And that's a very interesting topic as well. So for instance, we can say we have a winning value chain that allows us to deliver products and services very quickly to our consumers. Now, what is quickly? Well, Amazon delivers within 48 hours. Think again. Well, 90 minutes is the new standard. So how can you deliver something in 90 minutes? Well, you optimize your value chain for that. And there are already companies in London that actually, when they want to deliver a product, they basically push a message out and say, this product has to be delivered to this address within 90 minutes. And they create an open API. So there are, in the meantime, you know, around 30, 40 small logistic companies that actually take the API and write their own software to optimize against that and then bid on a single delivery. So they actually bid in real time on a delivery. So that means that the guy on a scooter can go in, get the package, and deliver it on time. So if you thought that 48 hours was the standard, think again. It's 90 minutes. And that applies to everything. You know, winning value chains today are not the winning value chains for tomorrow. So how can we anticipate that? How can we deal with that and make sure that we're doing the right stuff? So you got to change your business. So we're doing a big transformation in Philips. And today we published our quarterly results, and you'll see Accelerate is what helps us get there. And what is Accelerate about is basically creating these new value chains, these very flexible value chains that are digitally enabled. And that's why I have such a fun job. Because how many times in your life do you get an opportunity to work for an iconic company that's changing, and that gives you the opportunity to actually create the infrastructure and the plumbing for that company to be ready for the digital age. And that's what we're doing. So, as I said earlier, everything gets connected. Everything is full of sensors. So you can come up with completely new products. You know, Sean Carney talked to you this morning. They co-created a cooker. And actually, how did they co-create it? They had a community in Spain and a community in Germany. They let the people talk about how important food is. You know, not just the fun of cooking, but also how to cook healthily, and the social aspects of cooking. You know, cooking for your friends, for your family, and the importance of having a meal and discussing, you know, what's important to you. So it's more than just cooking. It's about well-being. It's about good food, good conversation, and making you feel relevant. Now, there's a difference between the community in Spain and the community in Germany. And these people started talking together. And out of it, actually, we co-created this cooker. Now, then we started thinking, what about if this cooker is full of sensors anyway? So you put your broccoli into it, and you can say, okay, cook it al dente or maximum vitamins. Or you can actually start exchanging recipes. So we can create now the APIs that that not only will tell us how this device is being used, how we can optimize this device, but we can start optimizing it through third-party APIs, through exchange of communities in terms of recipes, etc. And actually, we can do that for virtually every product. And we've done it for virtually every product. We started creating these scenarios. You know, what can the device mean? What need will the device address in a bigger solution? For instance, if we look at lighting, we now start selling lighting as a service. So we no longer just do the light bulbs. We do complete lighting systems for street lighting. But if you think about it, these street lights are actually platforms. They're sensory platforms because you can measure anything. You can measure what moves, you can measure the CO2 in the air, you can actually put tiny cameras. It gets scary, obviously. Some of this stuff is really borderline. But interestingly, the way people look at this is changing as well. People are more and more willing to share their data. Obviously, they want something in return. But even with this, you can start thinking of optimizing security, optimizing traffic, optimizing the air quality, etc. So each of these devices become data collection points for us. Now, we have a whole range of devices. At our top end, we have MRIs. They sell for around $1.5 million, sometimes $2 million. But basically, they're nothing but very, very expensive data collection devices. So what we do is we take images. Now we have 9 petabytes of images. So we capture all these images and we start doing pattern recognition on it. And that's what we're doing today. So we're giving it back as a service to the doctor. So it's not you take an image, but you overlay it with knowledge. And that knowledge helps a radiologist to make fast decisions because we give them the pattern recognition on this. We can give them the decision support tools. So they can dramatically improve their clinical workflow, so they can help more patients. Now, we send the patient home, we give them a little device that tracks all their vital signs. This device is connected to your phone, which has the health book. The health book is connected to a medicine dispenser. It's connected to a scale. It's connected to blood pressure. So you can track all your vital signs continuously and then correlate that with your images of your medical records. So the more contacts you build up, the more you know. And we're now working in China, actually, to basically continue where science stopped. So so in the medical science, a lot of work done on cardiovascular diseases. But we're finding out there are very specific conditions in China. Now suddenly we're getting all the data and we can continue the science. So when people talk about data science, that's what it is. I call it microscience. You talk to the folks from the quantified self, they're actually doing stuff that you can do yourself that used to be done in a lab with 20 people working on it and very expensive equipment. You can do it yourself today. You can measure your vital signs. You can say how you feel. You can measure your intake of caffeine, alcohol, water. You can measure your food, and you can start correlating for yourself. You can even now, buy your DNA and correlate it with your DNA. You can become a scientist at home. Now, imagine what we can do with it as a big company. So there are tremendous, tremendous opportunities not to just make all these devices smarter, but to create the big context. Because it's not about the data. We have plenty of data. It's about how do you correlate the data? How do you create the models that actually make it actionable knowledge? Yeah, you got to read that book, Third Wave. He saw it all. So just as an example, because we're talking about these devices, but what does it mean to your business? Because clearly, if a device comes connected, your value chain is not going to be the same. Everything will be different. What will be different? The way you sell it, the way you market it, your supply chain will be different. So let's just take a simple example, a connected toothbrush. So what does it mean? While you brush, you can actually measure you know, the pressure, etc. So you can see whether you brush well. Actually, the brush head has sensors, and the brush head can actually do plaque detection as well. But the brush is connected through Bluetooth or NFC to your phone. So you turn it on, and it will actually appear on your phone. You can register it automatically. If you register with your Facebook, we'll get your profile, we'll give you loyalty points because we want you to come back to us. Right now, very, very low percentage of our products get registered. So we don't even know who our consumers are. Now suddenly, we start knowing who our consumers are. We start knowing how they brush. So we can actually give them a personalized experience. So as an example, you can run a game on your phone, and the kids, you know, through this game learn how to brush. But they can play against each other, and their favorite character has a tune associated which we can download to the brush. So kids play with each other. We can obviously have recurring revenues through brush heads. We can actually service remotely. Today, more than 40% of all issues on our medical devices that have been connected for a long, long time are resolved remotely. And we think it will go up to 60, 70%, which means that virtually all issues can be resolved remotely. You don't need to send a field engineer. But if we send a field engineer, we're actually planning to give them Google glasses so that while they're repairing, they can actually look at the machine. And they can have relevant contents, relevant information while they're repairing the device. Now, we have to guarantee 15 years for this device for replacement parts in a big MRI. Now, what about even having 3D printers in the back of their truck so that some of these, you know, hard-to-find parts they can actually make on the spot? So just make you think a little more what we can do with digitizing it. So we'll have a lot of data, you know. Let's say 10 million people use this. We have the data of 10 million people how to brush. So we know more about brushing than anybody else. We actually want to hook up with the dentist because they're a great referral. Because if you start correlating brushing with dental care, what about selling the data to dental insurance? Because they can come up with a special premium for people that brush well, you know. And it's not crazy. Today we already have pay-as-you-drive insurance. So based on your on the way you drive, your premium gets adjusted. Now, a lot of this is, people will say, is borderline. Why should I share all the data? What's in it for me? I think that's the art, you know, making sure that we can link it back to the proposition. Because already today, people share way more about themselves than they did, you know, 2 or 3 years ago. Look at your own kids, the kind of stuff they share online. So think about what this does to marketing and sales. You know, you're no longer selling a product, you're selling a health solution. You're linking in with dentists, so you're creating a community with your dentist, major referrals. You're linking with third parties, maybe an insurance company. A lot of this stuff will go online, so people will not go to a retailer in the future because they can get the full experience online. Today, as I said earlier, if you can get something delivered within 90 minutes to your doorstep, if you can have a 3D experience that opens up the device, that gives you the full experience online, why would you still go to a retailer? So the role of the retailer is changing. The role of the retailer is what you see at the Apple Store today. It's all about the experience. The transactions will be done online. If transactions are done online, you have a full trace of everything that goes on with your consumer. So bringing all the data together is a huge opportunity. So we talk about data, but in Philips, we're actually looking at data on 3 levels. So at the base level is data management. So how do we make sure when we talk about a customer, we have the full information on the customer. We know what orders are outstanding with the customer, what profitability this customer has, how many times they have called our customer care. So the full 360. We also should understand who are influencing this customer, etc. So in order to do that, you need to have a view of how you define data and agree on that data. So that's what we're doing for operational data. Then the next step up is how do you do performance management? So we're talking about big data, we're talking about real-time data, but the reality in most companies is they get a monthly financial report. That's not real time. And it's also not big data, because a lot of these reports were designed 10, 15 years ago. A lot of our ERP systems were designed 15, 20 years ago. So you get what was designed back then. So we have a completely new need of data. And we want to give this real-time view of how we're doing. What happens with our customers, what happens with our consumers, how well we perform in our supply chain, how well we perform in our sales and marketing. So what we're actually looking at is, actually we copied this from P&G, so don't tell anybody, but we're creating business spheres. We want people to be inside their dashboards. We don't want them looking at their dashboards, we want them to be surrounded by dashboards. We want them to understand what's going on with their business and how we can optimize their business. But these are almost like preset views of the data. And yes, this is also big data. What we need as well is really advanced analytics. And that's where we start combining the whole. And that's where we start creating the new insights. And that may move up, because if we have these new insights, we may make them part of our performance management. Oh. So, how do we build our IT environment on this? So the first thing you got to do, which is a big decision, is start separating the data from the process, from the application. So that's a big decision we made. And there are a lot of implied decisions. So we said internally we have 6 major data domains, and we're actually creating what we call data hubs. So the first one is around product. You need to have a product 360, which means everything that relates to a product. What is the product family? What's the product architecture? What are the drawings, the engineering drawings, the software related to it, but also what is the collateral, your digital assets related to the product. So product 360. Then obviously critical is the customer, and we make a distinction between a customer and a consumer. A customer is, for instance, Walmart or a hospital. A consumer is an end user of our products. And obviously we have hundreds of millions of consumers. We also have hundreds of millions of patients. Already today, 250 million people touch our medical devices. So if we start really understanding what the consumers and patients mean for us, I think we have a tremendous source of value. But it starts by making sure you have these data hubs, and all data moves into the data hubs. Today, we probably have 300 customer databases. So by mid next year, we have everything in our customer and consumer data hubs. Then on top of that, you have the performance management, the stuff, the business spheres I talked about. But we separate it from the real big data. The click streams, the data coming from the devices, semi-structured data or unstructured data that you need to analyze and structure. Because there you need the full elasticity. And also you have different security requirements, because our operational data will have a very high level of security. Now the big data, you can separate the identity from the data. So all the consumer, the device-related data, click streams, etc., can all be in there and give us the full elasticity to work in a cloud-based environment and actually do very large-scale analytics on this. So what you see is actually we have product lifecycle management, we have CRM, we have the customer digital environments, we have our ERP systems, but we separate out the data, and then we have an integration layer that helps us put it all together to make the data move throughout the value chain. Because ultimately for Philips, it is about continuously creating the winning value chains and providing products and services that are relevant to our customers. So this is the architecture we're implementing. We announced that we're making a multi-million, actually hundreds of millions euros investment in creating this landscape, because this landscape will provide us the foundation to create winning value chains a couple of years from now. But it means a lot. It's not just the technology. Technology is a foundational aspect. But do we have the people that actually can analyze the data, that understand how to market in a fully digital environment? Do we have the innovation that relates to big data and that can enable our products to support this? So these are the transformations we're going through, because we identify we have to move to this world. We have identified that we need to make big changes in the way we run our business, but also in the competencies and capabilities of our people. But the good news is we're in the same position as most of our competitors. So there's nobody who has jumped way ahead in this space that are competitors to Philips. So I think we still have a big opportunity to get it right in the next couple of years so that we can then charge ahead. And I'm confident that Philips will be a completely different company 2-3 years from now. Once we have this up and running, we understand the power of digital, we understand the power of big data and connected products and consumers. So, technology is critical for our mission. So we leverage technology to provide health and well-being to consumers and customers on a very, very large scale. We're talking about billions of consumers and customers, and we'll get there. I think already now we have hundreds and hundreds of millions of people that touch our products. We're building a truly real-time connected company. No longer monthly, quarterly, hourly, real-time. And our end-to-end business models that will be driven by the specific needs of the markets, because doing healthcare in China is different than doing healthcare in the Netherlands or the US. The connected customers, products, and partners all integrated in the Philips value chain with intelligent connected devices and real-time data on how people use these devices, the context in which they use it, and how these consumers connect to each other in real time. Strategic use of big data and social technologies, and finally, a much more open company that will link in an ecosystem of partners, because our world is opening up by the minute, and Philips will take full leverage of that. So, a new real-time connected company, you will see it happen in the next couple of years. Thank you.
Thank you very much, Jeroen. I have one question immediately. I mean, Sean Carney mentioned it. Sure. Well, it would be great if you could also be an actor, anyway.
008.
Yeah. 008, yes. Sean Carney mentioned already a bit the traditional, let's say, business, let's say the verticals, the silos, etc., will change. Can you talk about that? What does it mean for a new connected company?
Yeah, so if you look traditionally how most companies work, including Philips, you have R&D, they come up with great new ideas, which is then, the business groups will look at it and pick and choose, and then they develop their own products. They set up the supply chain for it, and then they push it into the market. Yeah. That's the way most companies work. Well, that's not going to be successful. Yeah. So we got to turn it around. We start with the markets. We start with the consumers and the customers, and we start with the needs for these markets, like I pointed out. You start with, what's graying of the population in Japan mean? How can we build solution for that? In China, they want to really move healthcare to the full population very rapidly. So what does it mean? We got to do healthcare in a different way because they will be constrained by the number of qualified doctors they have. So these are typical market needs, and that's where we start. And then we bring people together. Then we bring R&D together. We bring Sean's organization together because the experience is going to be critical. And it's no longer experience of, you know, where's the button on this device? What's the full experience, both online and with the device and the services behind it in the cloud? Then you need sales and marketing people because they look at this is going to be a different way of selling it. And how can I have a supply chain that delivers this to, you know, 500 million people in China? So how do I optimize my supply chain for that? So you bring people together and it becomes much more of a collaborative approach to creating products and services. So it's no longer sequential. It's no longer starting with great R&D. It's starting with a need and bringing the R&D to come up with breakthrough solutions. So I think it's 180 degree.
Quite a challenge as well.
It is a challenge.
Are there any questions? Yes. Could you stand up, please, and wait for the microphone? Could you stand up, please? Because we.
My question is what do you think will be the bottleneck for Philips? If we look at it, because this is huge.
The bottleneck is typically cultural. Because people have been, you know, you're used to working the sequential way. You're used to beating up the guy in front of you in the value chain and beat up the guy, you know, behind you in the value chain. Suddenly you got to work together. And you got to have a holistic view of the business. So we started last year with what we called end-to-end, which is very simple. You start with the needs in the market, and then you bring people together. You know, a lot of people couldn't understand what end-to-end was. They couldn't understand what sales is and how you optimize sales, how you do marketing, how do you do product design and do a supply chain. But thinking through it end-to-end. So the process we're going to is the mindset will be the bottleneck and not the capability, because we have plenty of capability. We're a very innovative company. There's clearly leadership that wants to invest, that knows that they have to make the investments. But it will take, you know, it will take another couple of years before we have this all, you know, moving in the right direction. And I think that applies to any big company.
Other questions? Yes. Yeah, one second. Can you please stand up, because we are...
Considering you're doing a change of the whole company as a whole, and you're yourself saying it takes several years to have that implemented, do you think you will lose out to do smaller, more focused companies who are doing things like, you mentioned the example of the toothbrush, multiple companies are doing that right now. They're using methodologies like the lean startup, so they iterate much faster, prototype much faster. Yeah. How do you think Philips will compete with that in the end? Or will they just do the strategy of taking in these companies in the end and leveraging the supply chain that Philips has and being at a different point in the value chain at the end?
Yeah, I think we're not going to wait a couple of years, obviously. You know, you move first where you need the most speed to stay relevant, or better to stay ahead of the pack in the market. I think it's easy, actually, and you go to the Bay Area, everybody would tell you it's easy to come up with an idea and actually create a prototype. It's much harder to cover a market and have a supply chain that works with the right quality. So I think if we can combine that speed at the front and leverage our scale, I think we can compete with anybody on this. We have much bigger R&D. It's just we need to build in that agility into our organization, which we are doing. You know, we also can be agile, and we also can be lean. You know, it's not small companies that have, you know, the monopoly on being lean and agile. So I think we're proving already that we can be lean and agile in many areas. Now, what I talk about is before the whole company functions like this, that will take a couple of years. But you'll see a lot of our business groups and markets charging ahead. You know, as I said, I was in China last week, and there we're moving ahead, you know, at a speed which is unknown here in the Netherlands, for instance. So we have a global footprint. We'll go fast in markets that want to move fast, and then take that to other markets. So I think we're in a much better position than all these small companies.
There was another question over there.
Hi. I hear a lot of discussion today about hardware. So connected devices. I recently saw a talk by the Nike president of marketing. And he said, we've been moving from a hardware company, sneakers, to a service company, and I don't see that kind of tone of voice in the presentation you just gave. It's a lot of devices, but devices need to connect to a certain service. How do you see that challenge for your company?
I just explained it. For instance, I said we're moving from a provider of street lamps to lighting as a service. So I think we're also moving to become much more of a services company. But the hardware is going to be very important. The device is going to be. Nike will not be a services company unless they have a shirt with sensors in it and sneakers with monitors in it. So, and
quite a few years to get there.
Well, they're still not yet there. If you ask them how much revenue they get from it, it's probably less than 1%. So they're only at the beginning. And as I said, we're also at the beginning, but everybody's at the beginning because there are not too many examples yet. Everybody sees it, but it will go slow, and then it suddenly will go very fast. So, and obviously we're looking at the same. The toothbrush I talked about is a service-enabled device. So there is a cloud, there are data behind it, there's new models that create communities with dentists, etc. And we're looking at that for each of our products. And products are basically becoming parts of solutions. And a solution is a service, it's a digital experience, it's linking with ecosystem partners, etc. So I think everybody gets the Apple model. It's, it's harder to apply it to some of the areas that are not directly related to it. So.
There was another question over there. Yes. Yeah, microphone, please.
Thanks. What's your view on open data versus data generated by Philips sensors or products?
Well, I don't know how to answer that because, you know, clearly what people give away will be not something that gives them competitive advantage. So yes, they will open up their data, but sometimes they will charge for it. Sometimes they will just open it up because they want to create an ecosystem around it. So you first got to assume that every company is selfish, and you got to assume that they want to protect their IP. So whenever they make data available for free, there's always a reason behind it.
But we also see
with
the quantified self example that data is also generated not only by businesses, but also by people.
Yeah, yeah. And obviously the power comes when you combine it because there's also a lot of scientific data that is available. There's government data. There are now more and more governments that publish data and they have a data API. So the art becomes pulling it in and creating the models, the algorithms, the correlations, what have you. So there will be a tremendous amount of sources. You know, the quantified self, by the way, is not a commercially driven movement. It's really about, you know, how can it help me as a person live a better life? But for instance, I come from the financial services industry. A lot of stuff we're talking about actually was done in a charge way back. You know, you can go to Experian or Axiom, and they will actually know more about you than you want, and they sell that data. So they know exactly which jobs you held, what your tax returns was. They're actually collecting all personal data. They're creating full profiles, and they're selling back the profiles. So you can buy a profile. You can, even if you go on the black market, you can buy an identity if you want to. I think the going rate is about $10. So I cannot answer it, but you'll see different sources, and I don't think companies will give data away unless there's something in it for themselves.
Last question over there in the back. One second.
Thanks for your presentation first. We're all aware that here in Europe, the Internet of Things regulation risks to be quite strict. Do you see higher risks for Philips competing in European market rather than in other markets?
Yeah, that is interesting because if you look at medical devices, in the US you have the FDA regulation, and that kind of puts a brake on innovation. Now again, if you go to China, regulation is less. So there will be markets where things move fast. And if Europe over-regulates Internet of Things and their privacy concerns go overboard, then you'll see other markets just charging ahead. So I think the business will move where the opportunity is. And if politicians want to constrain the opportunity. And I think already a lot of the privacy laws are last century because people's mindset about privacy is changing. Everybody here Googles their own name. Google your own name, you'll be amazed what you find. So, privacy is already gone.
Okay, thank you very much.
Thank you.
So this is the end of the seminar. I hope you enjoyed it. I hope you learned a lot. I hope your view on big data and how you can deal with that has changed, and you have some new thoughts. So I would like to thank you very much. I hope you enjoyed it, as I said. I have just, let's say, administrative thing to say. Those people who will attend the workshops at the Philips Design Office, they have to go to the registration desk where you registered this morning, and there are some hostesses who will bring you through the Philips Design premises, and there also will be lunch only for the workshop people. I'm sorry. Okay, thank you very much for coming. Bye-bye.